This is the tutorial for Chapter 8, Section 2, titled Multiplying and Factoring, day number 1. And so let's take a look at our first problem here. It says to simplify each product. And so when we do that, we're basically using the distributive property. We're taking the 6h squared and multiplying it over this addition. So it kind of looks like this. 6h squared multiplied by 7. And then we'll go ahead and add on that 6h squared multiplied by h. And so we just have to remember some rules of exponents, which says you can take the coefficients, the numbers in front of the variables, and multiply those. So that makes 42, and I just have h squared. Over here, bring down the plus sign, and I've got 6 times by 1, no number in front of the h, so it's just 1, so that gives me 6. And then h squared and h, remember it's h to the first power here, h squared multiply to make h to the third. And so to simplify, we want to write it in descending order, so from highest exponent to the lowest exponent. So I'm going to just rewrite this as 6h to the third power plus 42h squared. So I just use that commutative property and just move this term in front of the term with the lower exponent on the variable. And so that's what I'll have for my answer. Looking at the next problem, multiplying y by each of these terms. So no number in front of the variable, so that means just 1. So basically it's just 1y multiplied by 2y squared. And then I'll bring down the minus sign here, and I'll do y times by 3y. And then I'll bring down the plus sign, and I'll do y times by 6. And so I go ahead and do the work. And again, when we're multiplying with the same base, like y is the same base here, that just means we add up the exponents. So it becomes 2y to the third minus 3y squared, and then plus 6y. And so that is our answer. And so over here, we're again multiplying each of these terms. So I do 7j multiplied by a negative 2j squared. And then I can bring down a plus sign and do 7j times by negative 8j. Now, last time what I ended up doing is I just brought down the sign, and I can do that. Remember, it's just like a minus sign I'm bringing down, and so I've got y times by the positive 3y. You can think of it like this. And y times by 3y makes 3y squared, but then I just have that negative sign in front. Or you can think of it as plus a negative, and that's what I did over here. And so I'm just doing two different methods. Whichever method you like better works for me, as long as you remember that one negative multiplied by a positive is going to end up making a negative. When we have two negatives multiplied together, that makes a positive. So 7j times by negative 8j, I'm treating that. And I can do that again with this one. Treat that as plus negative, then I'll bring down the plus sign and do 7j times by negative 3. And so no matter what, just remember one negative makes a negative. You're multiplying the coefficients, so I got negative 42 j to the third power, j to the first times j to the second makes j to the third, and then minus, because the one negative makes a negative again, 56j squared, and then minus 21j. And that would be our answer. So looking at this next one, here I have an 8a squared, so I'm multiplying each of the terms again. And so I've got 8a squared times by a negative 8, or a to the 7th power, and then plus 8a squared times by 7a, and then I'll do that same thing, plus negative here, so I'm treating that as plus 8a squared times by negative 7. So I do the work there, and I got negative 8a to the 9th power, I got to add up the exponents again, plus 56a to the 3rd power, and then over here I've got the minus 56a to the 2nd power, and that would be my answer. So moving on to this next problem here, I'm multiplying 11w by each of these terms, and so I've got 11w multiplied by w squared, and then plus 11w multiplied by 2w, and then plus 11w multiplied by just 6. And so when I do that work, I got 11w to the third plus 22w squared, because the two w's here, and then plus 66w. And that would be our answer. So that's multiplying a monomial over a polynomial. In this case here we had a monomial times by binomial in these cases. The other cases we had a monomial multiplied by a trinomial. And so we're just using the distributive property there. So let's take a look at the other type of problem that we'll see. And on this problem, we're doing the same sort of thing. We're going to simplify and write in standard form. And so we're using the distributive property here. So p times p makes p squared. And then over here we have p times 4 makes 4p. But then over here we have to do the same thing. Now again, treat this as a negative 2p. So you're taking negative 2p and distributing it over these two terms. So I've got negative 2p to the second power, and then plus 16p. Plus because the negative and the negative made a positive right there. So then they'd say right in standard form. Well, let's go ahead and collect like terms first. So I've got the p squared here, 1p squared, and a minus 2p squared is going to leave me with negative p squared. And then I go ahead and collect these two terms. They're the same sign, so I add. So it's going to be plus 20p. Again, don't change the exponents when you add, only when you multiply. And so this would be in the standard form because I've got the expression in descending order, going from the highest exponent term to the lowest exponent term. So moving on to the next one, same sort of thing. We're going to multiply the t over both of these terms. So it becomes t squared and then plus 4t. And over here, we do the same thing, t times these two terms. So it's plus 4t to the third power minus 2t. And so t times negative 2 makes negative 2t. So I want to write it, collect any like terms, but there's no terms that are like here. Oh, there are one set of terms. So let me go ahead and see those. I didn't see that right away, but now I do. So the 4t minus the 2t. So that I can collect. And so that's going to end up making a positive 2t. Now, the next term I'm going to write, it's positive, so I'll put a plus sign, is the t squared. So that term comes next, and then the 4t to the third power. That comes last. Well, that actually comes first because it has the highest degree term. So that would be our answer. So moving on to this one, we go 2q times by q and 2q times by 1. So that makes 2q squared plus 2q. And then over here we're multiplying the negative q by q and the negative q by negative 1. So it becomes negative q squared plus q. And so I go ahead and collect some like terms here. So I've got the 2q squared and the minus q squared. So that minus sign in front of the term, make sure you subtract those two numbers. So I get 1q squared, or just q squared. And then these two terms make positive 3 because it's 1q plus 2q's make 3q's. So my answer is going to be q squared plus 3q. So when they say standard form, they want it in that descending order, going from the highest exponent term to the lowest exponent term. So last one here of this type, we multiply 6c by each of those terms. And then I'm going to take negative c, and it's just multiplied over the 8c. So there's no number being added. It's like plus 0. So it's just negative c times 8c. So here I get 12c to the third power minus 24c. So 6 times 4 made the 24. And then here it's just negative 8c squared. So writing it in standard form means descending order. So I'm just going to move this term right here. I'm going to move it in between these two terms because that way it goes from the highest exponent to the lowest. So it's going to be 12c to the third minus 8c squared minus 24c. So the sign in front always gets commuted with the term as you are moving things. So those are the types of problems you're going to see on tonight's assignment. Good luck.